Should be recording now. Yep, I'm ready.
Right. Okay. All right. So the the Splunk bots data set, okay, is released by Splunk. It's an open source data set, and this is the third version. Okay. And this has been, it's not necessarily, I haven't noticed a trend of it being like every single year on the clock. But what they do is, this is the SOC challenge, the Security Operations Center challenge. Okay, so Splunk itself is a log aggregator. It's a system that's capable of collecting logs from lots of systems on a network, okay, inside of an enterprise network. So for instance, if you're a company XYZ and you set up a, every company is going to have its own local area network, which could expand to a wide area network. And there's lots of systems that are collecting transactions by customers or by internal customers, external customers, processes, whatever. And there's lots of user activity within the network, like users logging into things and, into systems like web servers. Customers or internal customers or people within the organization, IT departments, whatever, any kind of department, logging into resources that are in the cloud like AWS or Microsoft Azure or Google Cloud Services, okay? There's all kinds of activity that happens on a network. So what Splunk can do is, it's just an example of, the fundamental problem that a product like Splunk attempts to solve is that because all of these different systems are logging data over complex networks, it's very difficult to wrap any sort of analysis around it to detect an anomaly. In the terms of cybersecurity, the primary goal of an analyst is to identify an anomaly, okay? And anomalies would be behaviorally driven by either a person or a system, and the anomaly can be either known or unknown, okay? If it's a known behavior, a known system pattern, for instance, it's expected that when you log into an application on a network that you type in your username and password. And it's potentially expected that you type in the username and password incorrectly a couple of times. And then maybe there's a policy on the network where the user's credentials are authenticated. So when usually systems are integrated with some sort of user authentication service like Active Directory, for instance, okay? And so like when you're at USF, you type in your NetID, notice that you use the same NetID username and password for multiple applications at USF, right? So Canvas, whatever.
Active Directory.
Oasis, yeah, it uses a directory service. Mm-hmm. It may not necessarily be Active Directory services. I think right now they're using Office 365. They've used LDAP. They've got a mixed authentication environment at USF, okay? The point is that the normal activity, even if the user, we've all typed in our username and password incorrectly a couple of times, right? We've even locked our account, let's say, before, right? So let's say there is a policy on the network that says if you type your password in wrong 3 times, it locks your account for 5 minutes or 15 minutes, okay? Now, that would be considered perhaps a normal behavior, right? We all forget our password, no big whip, right? But what an abnormal behavior might be, well, it unlocks and then the policy is allowing this behavior to continue every 15 minutes, and someone just persistently keeps trying for days and days, right? Or whatever. Then suddenly, at some point, the activity in a network that is being logged by a system is representing an abnormal behavior at some point. Okay. Now, what is determined as abnormal behavior is determined by the administrators of those systems. Sometimes there is an abnormal behavior that a system administrator may or may not be, or it's unexpected, I guess, an unexpected behavior. Okay. If someone, another example would be, let's say an easier detection of an anomaly would be, let's say, Armando, you are the administrator of a web server, and you have a service account that you use to log in as an administrator. You don't log in with your credentials to systems normally. You use system service accounts. Okay, you could have local accounts that are local that only work on that computing system, that server or service. Then you can have networked accounts that can be used to manage services. And so let's say that you have, for instance, a web administrative account, and the website that your company manages is balanced over 3 servers with 3 separate operating systems that are running lots of services in order to run your web application. So let's say that your service account for these web services is called web_admin. Mm-hmm. And the password is whatever, right? You know, some complex password. So the expectation is, right, there's only a very few handful of individuals that would have access to that service account in IT and would be using it for administrative purposes, right? So maybe they're trying to patch the server. Maybe they have to log in to, work on the integrity of the database or something, right? There's some administrative reason why they're using that password. So the expected behavior would, a service like Splunk would pick up the logs of the web server where the web admin user logs into the web server, conducts some activities, and then logs off.
Right. So we,
right.
Like the expected behavior would be the IP of the administrator would be the one doing the request, and like do it maybe once or twice or 3 times. But it would be
and the expected behavior, let's say, has a window period of time. For instance, web administrators, they schedule their maintenance for login, I don't know, Monday, Wednesday, and Fridays between 8 a.m. and 5 p.m. Eastern Standard Time, right? But all of a sudden, the logs are picking up activity on Tuesdays and Thursdays at 2 a.m., right? And now, in an ocean of data, unless you are going every single day and reading these logs, now these logs can be thousands, they can be, a large IT shop for a class, even a class C network, it'd be a class B network, certainly a class A network could be collecting, who knows, certainly gigabytes of logs per day, at least, at a minimum, could be gigabytes of logs. Some could be in excess of terabytes of logs per day. Okay, just depends on how many transactions, how many services, how many things are being logged. So it's not humanly feasible to monitor all of these gigabytes of logs every single day, looking manually for any sort of anomaly. So anomaly detection it has to be automated. Okay, so one of the roles of cybersecurity for organizations, not the analyst part in an operations center, which I'll get to in a minute, but an organization has to invest in automated log, essentially automated log detection and analysis type systems. They're also called SIM systems sometimes, security information and event management systems. Okay. There are systems that aggregate tons of logs and then run rules that have conditions that says, you know, a simple rule would be if any login of web admin user is detected outside the maintenance window, then it should trigger an alert, and the alert would go to the IT department, right? And I'll get to the SOC in a minute, for investigation. Is this an anomaly, or was some sort of out of schedule maintenance, did some sort of out of schedule maintenance, out of maintenance window happen, right? Was there some reason why someone at 2 o'clock in the morning was logging into the web server and doing all of this stuff, right? Now, these are very laborsome tasks. The typical information technology shop does not have the resources to investigate every one of the alerts that are detected by systems that have rules that are looking for known anomalies, right? Or something that is not a normal activity, right? So oftentimes the company either has one of two choices depending on their level of resources. They're either going to have to hire an internal security analyst team, which maybe they can only resource one or two people, let's say, or that team, that small team, is responsible for responding to the alerts, and the first thing that they're trying to do is rule out whether it is normal or not. That's what they're trying to do, is if it's normal. Now, if it's normal and a rule was applied that thought that it was abnormal, then the local analyst has to determine, okay, do we need to add this anomalous behavior to the rules because we determined that it wasn't abnormal, it was normal, or if it was just a one-off thing that we had an administrator working from 2 o'clock in the morning on a Saturday, right, that it was just a one-off thing. So there's no reason to revise the rules. We just know to disregard this alert because we checked it and we talked to the administrator and he or she said, yep, at 2 o'clock in the morning on Saturday, I was trying to do an emergency patch of the server or something like that, right?
Right.
Now, under other circumstances, an organization cannot afford this team, so they spend a significant amount of money contracting to security operations centers. These are third-party organizations. Now, some large organizations stand up their own security operations centers if they have that kind of resources, okay? But some companies don't. They feel like that this is not within their scope, or their business model doesn't fit it, the resources, they don't want to spend on it. So they resource out to a third-party security operations center. So security operations centers can be stood up internally. Now, that's different than that small security IT team, right? An operations center would be responsible for someone in an operations center, an analyst, would be assigned a customer environment. Okay, whether it's an internal security operations center or a third-party security operations center. They're assigned customer environments, and their responsibility. These operation centers run 24 hours a day, 365 days a year. There's no such thing as a day off for an SOC. It doesn't, it's not in the business model, okay? Because security events don't take a day off, right? So their responsibility is, as they're assigned to the customer environment, what they're doing is they're analyzing all of the events that are detected by these security information and event management systems. Splunk is an example of an aggregator of these logs and would contain logs from multiple kinds of systems, and one could set forth a set of rules to detect anomalies within it, or they could actually query the database to investigate an anomaly. Okay?
Right. So
yeah.
So Splunk would be, it allows to listen to the network and have active real-time filters based on that, real-time alerts based on that.
Well, it depends on how they have it set up, but think of Splunk right now as having the ability to collect the logs. And let's say that they were using a third-party product, like there's the problem. See, here's the issue. The other problem in cybersecurity with companies is there's too many systems. There's no one system that does everything. Okay, it doesn't exist. Okay, so the market right now in cybersecurity analytics is to aggregate data that it has collected these logs, like Splunk and other vendors, whether they be open source or proprietary. So what Splunk is doing is it's collecting lots of data, whether there's rules applied or how well they configured Splunk, or they developed on Splunk, or they have a third-party product that reads the data in Splunk to determine if there's an anomaly, right? Just think of Splunk right now as the core aggregator for logs, but the application of Splunk depends on the organization and what they want to do with it. Okay.
When you say,
so maybe they could use a third-party product that analyzes the Splunk logs, and it real time is kind of tough, but because real-time analysis of millions of rows of data, I'm not sure how quick real time would be, but certainly quick, pretty quick. Depending on the resources of the company, there could have a product that could read the Splunk data and determine the anomaly. Okay.
And when you say aggregation, what do you mean exactly by that? What is aggregated?
Aggregation is not interpreted as a term of like a sum, an average, not that kind of aggregation. Aggregation in terms of assembling logs from multiple systems into one location.
Okay.
So everything is converged in. And so Splunk itself has a data structure that has to comply with whatever system of data it's collecting. So for instance, if you wanted to collect data from AWS, you would need to have all of the fields and data structures that you can collect from AWS using AWS's plugin for Splunk or API. Okay. So Splunk will come kind of scaled down to its core, and then as you bring on other systems, depending on their data structure, the underlying data structure of Splunk begins to expand. So each Splunk environment set up in each company may or may not be the same. Does that make sense?
Mm-hmm. Thanks. Yeah.
Okay, so now back to the SOC data. So now that you understand the role of an operations center, the operations center, the security operations center's role of an analyst is to monitor the customer environment and essentially respond to alerts that are generated and or whatever custom needs there are for that customer in their environment, whether they need to extract data from Splunk or whatever they need to do to automate the, the analysis of the data must be automated to determine the anomalies, right? Now, sometimes if a rule doesn't exist, an anomaly happens in a secondary sense that then is reported to the operations center. So for instance, let's say that there was not, Splunk collected some data and they were using a third-party application that was analyzing the data in Splunk to determine an anomaly, and then an alert would go to the operations center. But then let's say that no alert was generated, but users start reporting that their laptops are crashing, right? Or the network crashed, right? Some kind of an anomaly event happened in real life, but it wasn't detected by the rules. Automated.
So you need to modify the rules based on that.
Well, first, before you modify any rules, the anomaly event that happened in real life gets reported to IT or whatever their processes are. Eventually, it gets to the analyst, the security analyst. And the analyst is detecting a denial, the network administrator, gets, first the users say, we have no network, right? We got no internet available on our local area network in our company. So then the network administrator gets hit up. Network administrator begins to locally investigate the problem and cannot determine the cause, but for some reason, ports were disturbed, locked, changed. Something happened that was abnormal to the ports that manage the access of applications or the access of users to the network, right? Now, the security infrastructure that logs information and events from the network did not have a rule that detected any event that led to a denial of service attack on that network. So the network administrator reports it to the security team and gets the security operations center involved. The security operations center then is now looking for an anomaly that was not detected by any rule. So that's an unknown. Right at that point, there's an unknown going on. We have no idea what happened. Now we know the result of the attack was that there was a denial of service to the network. But what we don't know is what caused it and how it happened, right? So security operations centers, when an analyst is analyzing any sort of cyber event, right? Whether they're trying to determine if it was an automated generated event, if it was an auto-generated event and the system itself identified an anomaly and the analyst is trying to determine, okay, it's a false positive, meaning it's a false anomaly. It's okay, right? Or the analyst is trying to work with a completely unknown situation, such as the denial of service attack, where they don't know what happened and they have to investigate and look at the logs. Okay, no matter whether it's a known or an unknown, they're trying to rule out anomaly or they're trying to figure out what the anomaly was, no matter what the approach is. Analysts have to use a methodology for investigation. Okay, they have to use a methodology that is consistent so that if analyst A, analyst B, and analyst C were to be investigating same or similar events, they would be using the same method of analysis to derive the same or similar or result or recommendation to the customer to remediate the problem. Okay, so here's the next problem. There is no industry standard of analysis. And here's what I mean by analysis in this sense. I'm not talking about analytical methods like machine learning methods or AI methods or any of that. I'm talking about the human cognitive tasks, right? The decisions that an analyst makes as they're investigating an event. Now, the analogy that cybersecurity often uses is like a criminal investigation. So let's say that a crime was committed, a robbery, someone broke into somebody's house. A robbery was committed, right? No one was home. Nobody was home, and the family was on vacation. They come back home and all their stuff in their house, their valuables are gone. They call the police, right? The police comes, they verify, yeah, there was a robbery that took place. They bring in an investigator, right? The investigator uses a criminal investigation methodology.
A standard.
Yes, that must be followed, because if they don't follow it, then they're either going to miss something, or perhaps they're not in compliance with the law in the investigation. For instance, someone disturbs the crime scene, right? Like there's evidence everywhere and they need to take fingerprints, and the police just lets everybody in to start touching things. And now the investigator has lost the opportunity to check the fingerprints, right?
It's kind of like if you discover you've been breached, and that some group has access to your architecture files, right?
Yeah.
And you could have a threat of a bigger data breach in the future, because they know your information, but you don't know exactly what to do because there's no standard, right?
Right. So so in cybersecurity, each company has its own methodology, many of which are proprietary.
Right. Okay.
Like they call it proprietary, but the reason why they call it proprietary is because maybe they're doing, as part of the steps that they do, it involves using software that they've developed, or they each have their own little way of doing it, and little is known, very little is known about how companies conduct investigations. What I mean is the actual proprietary steps that they take, the things that they do, the way that they're training their employees, everything that they do from the moment that they get the alert and the concern from the customer, or the information from the customer, to the very end point at which they provide a recommendation to remediate the problem to the customer. There's very little that's known, and the reason why, it's not that it's not known, it's known. What I mean is that in the public knowledge, it's very poorly understood and poorly known. It is well known within proprietary models. So good cyber security operations center, and there's operations centers not only in the private market, right, but there's also operations centers that operate in governments. Like in the US, we have, the NSA has its own operations center, right? Department of Defense has its own operations center. All the military branches have an security operations center. Okay, so they're obviously have methods that they're not going to share with anybody, right? They're not going to tell you, oh, this is how we investigated this state actor who attacked these federal systems. Do you understand? Amazon is not or Microsoft or Google or whomever, they're not going to reveal their proprietary internal stuff that they had to go through in order to figure out what happened.
Right. It's not also their intellectual property, but it's also a security measure for the attackers not to know what they're doing. Right.
Right. They're not going to advertise. And so the operations centers, who are the third party, Google has, I'm sure, its own security operations center, but then you've got a smaller company that has a third party security operations center, and that third party security operations center is not going to spill its beans on how it's investigating all of its customers, right? I mean, they'll give you a general sense of what they're doing, right? They'll tell you, yeah, we do this A, B, C, D, E, F, G. Like, in some sense, that's known, right? But they're not going to tell you, oh, we're logging into this customer's system to investigate this whatever. Well, that system by that customer may be proprietary that they don't want anybody to know about. You see what I'm saying? So that complicates things a little bit. The other thing that complicates things is that not only is there not any well understood consistent methodology used by investigations. I mean, some people put this in the area of forensics. There is a lot of work done in forensics to help people understand how to approach the individual technologies, right? So, for instance, if it was a networking event, well, intuitively speaking, to forensically investigate that network event, you would need to investigate the network equipment, right? You need to, we're not talking about the specificity to the technologies, but the overall methods. There's a higher level of methodology used before you get to the layer of specific technologies. Okay.
So that specifics is not standardized. That's what you're saying.
Yeah. Yes. So now the other issue is that there's very little in the way of understanding the overall experience and knowledge of any given analyst. Okay. The only controls that are out there for knowledge that security tools that firms can use or security operations centers can use, they've got certifications out there like Security Plus and CISSP, and there's a whole host of cybersecurity certifications that you can get that an organization says, okay, I know that Armando has Security Plus, so he understands these fundamental concepts of cybersecurity. So that core piece of knowledge is sort of put into a bucket, and the expectation is that you've got that certification, so you have a general understanding of that content.
Right.
But there's so much beyond investigating cybersecurity events than something that's found inside of a certification. It's a process that, have you seen it before? There's a creative component to investigating things that get really complex, especially if it's something that's unknown, right? If it's known, then there is, for a lot of the known things, a lot of the known malware and things like that, the phishing events, there is a lot of very well known and well understood and very well scripted ways of investigating certain types of events.
Right, but there's always something new coming up.
Yeah. So there's a good percentage of cybersecurity events now that have been collected where there's a high percentage of success for remediating the problem with a majority of well-qualified analysts. Okay. people that have, proven themselves through certification or through experience of just working with customers in an operations center over the span of a year or two or whatever, right? But then all of a sudden there's something that's new. There's always something there's new. There's what's called 0-day exploits. These are like events that happen that a technology has been exploited due to a vulnerability that some malicious actor has discovered, and the vendor is not aware of it yet. So for instance, if there's some new like Linksys router that you get from, the store like Walmart or Best Buy, some new model comes out, right? And a malicious actor finds a way for a vulnerability in this device. Now, they take advantage of this vulnerability and they start propagating and automating attacks based on what they know before the vendor is even aware of it. And in many cases, before operations centers even have it built into their anomaly detection, right? At this case, something is new. The analyst may not be able to handle it, and so they elevate it to an engineering team or other teams that have the capability of creatively solving a problem that is completely unknown.
Right.
And when they detect it and they figure it out, then they have different ethical responsibilities that they have to do. They have to, do they inform the vendor? We have a 0-day exploit you need to be aware of. You need to have it patched. We have customers that are being compromised because of this 0-day exploit. This is what we think is the solution to the problem. This is what we're doing to patch it right now. Fix it, right? So there is a sense of skill level by analysts that, how do you train that, right? There's no certification for that. There's no, there's no textbook answer for that. There's just somebody, this person has been touching technology for so long and they've done so many different things, they're able to kind of put the pieces together and figure out and solve the problem. Okay, so that's another dynamic and another problem. So back to this SOC data set. This SOC data set by Splunk offers a competition, much like what you guys have experienced in these hackathons and stuff, right?
Right. So there's a lot of unknowns.
Right. They've got data that's in there that has been offered up from real, they're either real situations from real systems, and they probably changed, like the IP, certain identity of the customers and whatnot. Or they're situations that have been reproduced in a lab environment, a controlled lab environment. And then they made sure that it was logged in Splunk. So they collected all of these different scenarios and shoved them inside this data set. Okay? And they offer up a competition from analysts from all over the place. I'm not sure how far and wide the audience, the competitors are for this, but it's a pretty wide set of competitors. And they come in and the competition presents to the analysts very little information. They'll say, you need to answer this question in the data, and it's very basic. Go. Right? And so while I'm explaining this to you, if you could bring up that Microsoft Word document that I sent you.
Yeah.
Open that up and I'll explain it. You're recording this whole thing, right?
Yeah, I will. I'm recording.
Yeah, because this is extremely valuable, and save it and we'll figure out, we need to share this. Maybe I know there's a way we can export it as an MP4 too, because I'm going to want a copy of this. Because I've never explained this verbally to anybody.
Yeah, I can. This will get pushed to Microsoft Stream, and then they can download it as an MP4.
Yeah, because I want anybody interested in this to kind of hear this. Okay. So here you've got this Microsoft Word document. So kind of just make the document where that's the only thing we see.
All right.
You might have to download. You might have to just download. Yeah, click the little download and just open it in Word.
I said not downloading.
Yep.
Oh,
there you go, and then just open it. Yeah. And then let me explain here when you share your screen how to work with this SOC data.
1 second. It's not showing.
Yep.
There we go.
Okay. So make it a little bigger. Yeah, there you go. Great. Okay. So here's an example of in this data, in the Splunk data, where what I did was I contacted the event organizers after the contest is over, which it's over. So this data set, I think, was available as March of this year, of 2020. Right.
And so this is the boss of SOC competition that we're talking about.
Yes. So the organizers of the event offer those 3 spreadsheets that I sent you, and I'll go over those in a minute. Just don't open those yet because I want to talk about this. They offer a set of hints, so questions, hints, and answers in the data. Okay, so what they're doing is they offer these up to people that want to either test their software, if they're trying to develop some sort of software that plugs into Splunk and determines anomalies, right? Or if they offer it to researchers like me that want to use the data set to investigate and these types of things. So these questions, hints, and answers were provided to me. I requested them. They sent them to me in the form of spreadsheets, and they offer insight into the anomalies. Okay? But what they don't do is fill in the blanks. But what we do know is we have a direction in the anomaly that's found within the data. So the fun part of working with the data is, since we know what the beginning looks like and we know what the end looks like, what I do is I document the journey of getting from A to Z. So A would be where we start. We know where we're supposed to start, and Z where we know where we're supposed to end. So there's no secret to the answer to the problem. Okay? But what we get along the journey is a lot of information. Okay? So it's not to say that what I have come up with is necessarily the best or the only path to answering the question in the data. Okay? And in this example, what I'm doing is stepping you through a methodology that I use based on what I've learned with working with one of our industry partners, and that we train at USF. Okay? And we use it in a training program. that we have set up for cybersecurity analysts, and we work cooperatively with the partnering firm. So this doesn't get into their proprietary systems or anything. It's just a basic approach to conducting an investigation that we teach students at USF. Okay. And they of course have their own internal spin on all of this that we're not privy to. Okay. But it works for basic investigation of things. Obviously, the knowledge of the analyst, which we don't have access to. So the proprietary company has a content management system that would be involved in their methodology to investigate this event. Now, I don't have access to that company's proprietary content management system. The content management system that a security operations center has includes all of the experiences they've had since the beginning of their operations center of successful investigations. Okay? We don't have that access to that proprietary method for this, which is what's making what I'm doing here non-proprietary. It's more in the approach of how I'm coming up with my own content. So essentially what we're doing here in this investigation is collecting our own content in this competition. The analysts have to collect their own content. They don't get the advantage of using their company's proprietary content. You get it?
So we need a whole process developed by ourselves. We can look at general data of how companies used to do it,
right?
But there's some
without the advantage of your dictionary of sorts. Like it's kind of like you find a word and you want to look up in the dictionary the meaning of the word. Well, it's like you're looking at things that you can't use your own proprietary dictionary, your own proprietary encyclopedia, right, collection of information. It's just whatever you can find on your own. Now, what they did for us is they gave us the answers. So all we have to do then is collect the content, okay, that matches the answer. However, it's not to say that the content that I've collected and how I did it is the best or the only way. Certainly not. So knowing that, looking here from the top, start from the top of the document. It's called Query 200 or number 200 because in the document that they provide, they give us all of the questions that they gave the contestants in the SOC contest, and those questions are numbered, and this number was called 200. Okay, and so the question that they asked was list out the IAM users that accessed an AWS service, either successfully or unsuccessfully, in Frothly's AWS environment. So obviously Frothly is the anonymized customer, right? And they give a hint, a guidance, and they say, look for comma separated without spaces in alphabetical order. Example, the IAM users are A. Jackson, M. Jones, and T. Miller.
So
right?
IAM would be the equivalent of AD in Microsoft or in Azure, right?
Mm-hmm.
Okay, just making sure.
So these would be the user identity is the credentials, the user, and this is AWS. And so what you would then, okay, like just to tackle this problem, that's all the contestant got. That right there, that's it. Where it says list out IAM users in green, and then you see the blue and the yellow and the purple. All they got was that. Okay, so now they have to find that answer. And it will also lead to anomalous behavior in the data as well. Okay.
Right.
Now,
So we have.
the question isn't specifically about anomalous behavior per se, specific anomalous behavior, but the data leads to activity that is anomalous by users within that AWS environment, which could be asked in a different question at a later time. So I use this as an example to show anomalous behavior by a user in AWS environment. We don't know what the anomalous behavior is, but we're looking for users. We don't even know the users' names. Now, they gave us a hint. Now, they don't give the contestants the hint. I don't know what the rules are. I think they lose penalty if they ask. I don't know what the rules are for hints, but they gave us the list of hints. I don't know if the users or the contestants can ask for hints. I'm not sure. And then they gave us the answer. So the hint was use AWS CloudTrail as the source type and look at the values within the user type field. Okay, so what this is doing is it's telling us in Splunk, if we were to identify the IAM users, so first of all, you would have to have some knowledge about the technology of AWS. Like, if you know nothing about Amazon Web Services, right? You're wondering, the first question you're asking yourself is, what's an IAM user? IAM user, what is that? Right? I don't even, like, the person could have no clue what that is. So already you're at a disadvantage if you're an analyst and you have no clue what anything about AWS, right? How in the heck do you go from here, right? So you would need to investigate. A lot of analysts they're either going to have to Google this stuff, right? So they're going to have to go into Google and say, AWS IAM user, what the heck is that? Right? Or maybe they go take some AWS training. Or maybe, it's like I said, they have proprietary methods in their company and they have a training for AWS internally. Maybe they got a content management system that has really big helpers. If you see anything that says IAM user AWS, this is what it means. It's a user that logs into AWS, blah, 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 something like that, right? So there's some knowledge that has to happen here. Then in the hint, AWS CloudTrail, there's some investigating there. What is that? What's this source type field? What's the user underscore type? So where is this coming from, right? So AWS CloudTrail is, you would have to figure out what's that. And so you may have to Google that or access some third-party information or some internal information to understand what is CloudTrail. Well, CloudTrail is the service provided by AWS, by Amazon Web Services, that logs all of the activity. Okay? Of the instances running on AWS service instances running on AWS. So for instance, if there's an EC2 instance, which, okay, you don't know what EC2 is, right? It's a virtual machine that's running inside of AWS in the cloud, and they call them EC2. Elastic Computing, EC is Elastic Computing 2. So these are instances of virtual machines that have the ability to elastically expand and contract in size and CPU and memory and other configurable elastic properties of a computing system. So then it gives the answer, and then so source type and user type, those are fields that are collected by CloudTrail, which is the service in AWS, and those fields can be found inside of the Splunk logs. then we got the answers. The contestants obviously didn't get this. And those are the users. There were 1, 2, 3, 4 users: bstol, bton, Splunk Access, and web admin. Well, I found anomalous behavior with the web admin user. Okay, now, to answer this question, do you see that query there?
Index equal bots.
Yeah. Now, do you have Splunk running right now?
I do. I tried running it, but okay. So I'm to share my screen. My
Yeah,
Splunk
we
instance.
troubleshoot Splunk in this. Well, just show me what your issue is, and then because we don't want to kill this video with troubleshooting your Splunk instance, but
Let me just share real quick to show you.
yeah.
So here I have Splunk.
Okay, great. So close that and just go to the search right there and paste that query that's in the Word document.
Right.
Yep, run that. And wait, just wait.
Seems like it doesn't find it though.
Okay, hang on. It's running. Just give it. See if it. Okay, we'll come back to. I'm wondering if you've got everything loaded in. So we'll look at that. Okay, so let's go back to the Word document and then we'll troubleshoot your Splunk environment after this. We finish recording. Okay.
Sounds good. I think it's an issue with how I imported the data.
Yeah, the data is probably not set up for certain. We'll troubleshoot that in a minute. Okay. So anyway, this query, just like you copied and pasted it in the Splunk environment, if it has a syntax, the index equals bots v3. So bots v3. So Splunk has indexers in it. Okay, indexers that point to this data is all grouped in this whatever bots v3. Okay, could be millions of rows indexed under bots v3. So how did I know that? I knew that through the documentation. If you look through the documentation they provide on GitHub. Earliest equals, so there's a space, earliest equals 0, meaning where the source type equals AWS CloudTrail. You see the hint, source type was a field, and the value is set to AWS CloudTrail. The user type is a field, and the value is I am user. And then there's a pipe, top limit equals 0 returns all rows, and we wanted to return the username. Okay. So we'll spend another time how do we analyze AWS, right? I mean, analyze Splunk. I don't think that's in this recording that we're doing right now. That's just too much. We'll do a separate recording for that, okay? So anyway, what happens is right here, we've got a return of the AWS users that answers that question. And then what I do is, we won't go through this whole document. We'll do a separate session where we actually get into the analysis of the method of analysis. But then I go through a whole series of steps of trying to determine, looking at each of these users, trying to determine what is normal and what's abnormal. And the document that we step through, if you go all the way to the bottom of the document now, or close to the bottom, keep going. And I go through a whole bunch of different things. And then you get to the bottom and then keep going. And then there's, keep going. Oh, go up. Sorry. If you go up a little bit.
That's the end of the file.
Right, go up to the narrative portion. And right there, based on all of this evidence, I provide, a narrative which then summarizes all of the different activities involved in the investigation. Okay, And so we'll spend another time, not today, we'll go through all of this document, but the important thing, go all the way up to the top of the document. The important thing to realize is that the way that these Splunk data sets, or the Splunk to interact with the data, is we start by looking at these questions, hence, and answers, and that leads us to getting a subset of information in the form of a CSV that would give us a big chunk, a subset of chunk of the logs that then you could hand over to the data science team. And the data science team can then say, okay, you've handed me a huge collection of information that includes anomalous behavior within it. Now, how can we detect this if given the same or similar data? You know, what can we do with this now that we know, okay, here's the story that's told in the analysis. This is the context of the data. So this document, the analysis, the cybersecurity analysis using a methodology of the data included in the Splunk data set, right, to answer specific questions that lead us to anomaly, that document becomes the context along with the CSV that matches the document, so that, you know, the document says, okay, here's all of this information. Now, based on all of this information, here's a CSV that includes the anomalous behavior that is inside of Splunk, right? The logs that we now can run, you know, a deep neural network or whatever, right? To classify or say that this is or isn't, use this to train our model on this other data set that's included in Splunk.
So we could run a classification model
right. You know, this would give you, would help you with the classification process. As an example. Okay, we could talk more about what models and data models and things like that later, but I'm just saying as an example. So the analysis in Splunk leads to the data set, which you then extract as a CS, which you then put into your data model and run the AI, machine learning, whatever, to essentially classify the anomaly or whatever. If you can think of before, right, when I said, what happens when an analyst gets something new that they haven't seen yet, right? So what you can treat this data like, even though I'm sure that a lot of these have roles in customer environments and security operations centers, but we're not privy to that, right? But you can treat this data set as a means for using the AWS infrastructure to build data models which detect anomalies, and those anomaly detections can be used on customers that are using the Splunk environment. Do you understand? So essentially, you're like building the rules in the form of analysis, data science. Does that make sense?
Right. Yep. It's building our own proprietary model, right? Without being proprietary.
Yeah, because this is the need. Remember, I started out by saying little is known, right? Little is known about what a proprietary company could be doing, right? So we can't work, in this case, we wouldn't be working with, this is a data set that is provided, that is open source, that can be used for the purpose that we are using it for right now, to build software, to do data analytics, data science, to do research. It is real. These are real things. They've been anonymized or reproduced in a lab environment.
And the good thing about this is that once we set up the competition for every team, that means there's multiple ways for a team to create their own model and set up the process their own way, right?
Right, to determine it, because everybody would be competing just like companies, right? So companies would run a same or similar investigation. I'm not saying my results are perfect, right? But I know that I got to the target, right? But every company to some extent is getting to the same target. They found this event, they found this information, they determined that it is an anomaly, it's abnormal, right? Great. They made a recommendation to the customer. You need to whatever, change the password of this admin user. You need to harden whatever the processes you're using for, password control or refresh or whatever, right? There's a remediation to the problem. But since we couldn't detect it to begin with, now we need to set up some sort of anomaly detection. So each company is going to have its own proprietary, right, anomaly detection. They're not going to share that, right? So what you're doing is, with an open source data set, you're using the knowledge of cybersecurity, because they have, I think, 50 something questions included. So we've got 50 something events. We know there's over 50 anomalies inside this data.
All right.
So that's a lot of test cases, a lot of use cases we have in this data. Okay. This is just one. Okay. And so what it requires is the cybersecurity team, we've got to investigate the data the best we can to get to the answer and try to get a collection of data. We'll be able to identify the anomaly in the data. We're not going to have a problem identifying that, but because they tell us the answer to it, right? It's just getting the largest data set we can that gives us enough information to work with to build whatever kind of algorithm we want to detect, to predict the anomaly.
Right. So that's why pulling all the data into a CSV doesn't make any sense.
No,
looking at the question first. We need
it
to look
makes
at the question.
no sense. No, because it's like if you had 100 million rows of data, what good is that? Because inside that is a spaghetti of all kinds of anomalies, and you need some definition. You need a definition that, this right here in front of you is a complete analysis that defines a case where this was an anomaly. And you need that intelligence to give to the data science team so that they can properly identify features or whatever, something that would predict this anomaly in the future. And the cool thing about this data set is that it includes a whole bunch of AWS technology inside, it includes AWS anomalous events, which just works out great for you.
Right. The process seems kind of a loop going back and forth between the data science team and the Splunk team or the cybersecurity team. Because the data science team needs to be the one asking the question first, so that the cybersecurity team can pull the data from that question.
Well, no. The questions have been initiated by Splunk, gave us the questions to start with, and then the cybersecurity team collects the collects the data to answer the question, and then they have a big chunk of data, right? And then they give the data science team and say, all right, look, here's the context, here's the question, here's the data. Now build an algorithm that predicts this pattern or identifies this pattern or whatever approach you want to take. And then we, you know, that's a huge contribution. I mean, to AWS, to the world, to anybody. That's a contribution.
Right.
Because you're using science to solve a problem that the world is having that's real. And that's why they have these competitions with these real problems to see, you know, how are people doing this? How are they investigating it? What are they doing? How did they find it? What did they find, you know? And how can we make our technology better so that it could find this, and all those things?
I'm just trying to differentiate what we're doing here with the boss of the SOC competition, right? So whatever we come up with here doesn't necessarily need to follow the format from bots, right?
No, because now this document you see here, I made all of that. That had nothing to do with that competition. That's my method right there.
Oh, okay.
That document has nothing to do with Splunk or bots, SOC, none of that. That's me making my own method of how the process I use to investigate it, based on ways that I've been training students with a firm in a cybersecurity training program to help analysts.
So what we have from them, apart from the data set, is the questions.
We train students at USF. Huh?
So apart from the data set, what we have from bots is just the questions.
Yeah.
Yeah.
Okay. Really, all they give you is the questions, the hints, and the answers. But you'll need the security team to work with me, and we could start with this one here already. This one is, it's got thousands. I don't know how many thousands is in this data set. I have a data set for this one already that you guys can start with.
And should we aim to answer all questions, or should we pre-select?
It's up to you. You guys can talk about that. But as long as you understand the approach. You understand the whole picture of what you're trying to do.
Yeah, we need to set up the.
You could probably stop recording now, because that was kill the recording, because it's been recording for a while.
Thank you, Clinton.
And then we can just talk about. Yep.
Just stop the recording.
Yeah, that way they can